Alright, let's take a look at these two more examples. So for this first one, we have 2 root 3 times 4 root 7, and we want to simplify this. So in order to simplify something like this, what we're going to do, we're going to first multiply our coefficients together and then multiply our radicals together. Right? So we can rewrite this as 2 times 4 times the square root of 3 times the square root of 7. And now we just have to simplify what's in each set of parentheses. Right? 2 times 4, that gives us 8. And then square root of 3 times the square root of 7, that's the square root of 21. And then the square root of 21, we can't do anything else with that. That can't be simplified anymore. So we just have to leave our final answer like this. So 2 root 3 times 4 root 7, that's going to be equal to 8 root 21. Now let's take a look at this second example. We have the square root of 15 over the square root of 5. Well, we can rewrite this as the square root of 15 over 5. And now we can simplify this 15 over 5, right? We know that 15 over 5, that's equal to 3. So this becomes the square root of 3, and this can't be simplified anymore, so we're all finished. So the square root of 15 over the square root of 5, that's going to be equal to the square root of 3. Now let's take a look at how we do what's called rationalizing the denominator. So rationalizing the denominator is another way to simplify that removes a radical from the denominator of a fraction. For whatever reason in math, it just makes it a little simpler if we don't have any radicals in our denominator. So if we want to put a radical expression in its simplest form, we have to make sure that there's no radical sign in the denominator. So let's take a look at how to do that. We can see that we have the square root of 5 over 3. Well, we can rewrite that as the square root of 5 over the square root of 3. Now we want to rationalize the denominator by getting rid of that square root of 3. So to do that, we can multiply both the numerator and the denominator by the square root of 3. And when we do that, in our numerator, now we're going to have the square root of 5 times the square root of 3 is the square root of 15. And in the denominator, we have the square root of 3 times the square root of 3. Well, the square roots get rid of each other. So now we just have a 3 in our denominator. Now let's take a look at how we would do it for our second example, 4 over the cube root of c. So we have 4 over the cube root of c. Now, in order to get rid of this cube root, we need to end up with a c cubed under our radical here, right? Because if we have the cube root of c cubed, well, this is equal to c. This power of 3 and that cube root, they kind of cancel each other out. So in order to do that, we're going to have to multiply our numerator and denominator by the cube root of c squared. So we go ahead and we do that. Now, when we do that, we have 4 times the cube root of c squared in our numerator, and in our denominator, we have the cube root of c cubed, right? And now we know that our exponent of the power of 3 and the cube root, they get rid of each other, cancel each other out. So we'll be left with 4 times the cube root of c squared over c. And now we're finished.